Hello everyone, my name is Konrad, and it happens that I will show you the presentation that is 80% the same like the previous one, because it happened because it is all about zero knowledge proofs, and there is also topics about Starknet and so on. So you will have a chance to rehearse the knowledge, and also maybe I will show you a little bit different stuff. So my name is Konrad, as I said. I'm a .NET developer, which is a nice language, by the way. If we have .NET developers here, hello. But I'm converting to Web3 also, and that's why I'm also here. So in .NET, I'm working for 12, 15 years or so. But as I said, I'm involved now, for example, in Web3 as a consultant in Nethermind, which is, maybe you know or not, is C# based client for Ethereum, which also has this Juno client written in Go for Starknet and so on, and also creating this hard fork awesome initiative that we are attending today, and also creating a startup which is Web3 startup for writing books, because I wrote a book and I thought, so if I know how to do that, let's migrate the idea to the Web3. And in general, this presentation, because I have completely no idea what's your level of knowledge about the topics. For example, how many of you knows what is a zero knowledge proof? Okay, that's good, not so many. Because all the previous talk and this main talk is about zero knowledge proofs that are utilized by these technologies. And we can start from this blockchain trilemma. Probably you heard about it, that it is not so easy to create something that is both scalable, secure, and decentralized. Some chains are supporting 2 of them, on others another 2 of those properties, and so on. So scalability is the main problem. For example, Ethereum doesn't, it is not one of those that are, let's say, treated as super scalable. And we are trying, Web3 and blockchain technologies are trying to provide some scalability solutions, and we have many of them. For example, and they are named somehow. I'm not sure if there are super standard names, but typically we are saying about on-chain scaling, like you can improve the blockchain itself to have better scalability, like sharding and changes that are going to be added to Ethereum. But we have also other solutions like sidechains, which is another chain that is running independently to the original blockchain and somehow allows to combine both to provide better scalability. The Polygon is the typical example. Others are rollups, and all the previous presentation were about rollups, which are just the idea that let's batch the transactions and make the second place where they are somehow executed and then cooperating with the original blockchain. All of them are so-called layers 2. And in general, my talk is about the future of blockchain, because I believe the future of blockchain is somehow related to layers 2. Also, Vitalik, our guru in Ethereum, is saying so, that in general the whole Ethereum roadmap is rollup centric, because this is the main goal of the Ethereum itself, to make it more rollup friendly, to make it more scalable, because we need to support mainstream. We need to have tens of thousands of transactions per second if we want to, the whole world will be using it, not 15 transactions per second. That's not satisfying. So there are various technologies of those layer 2 and various ways of implementing rollups itself. Optimistic rollups that you may know, like Optimism, for example, are called optimistic because we assume that everything is fine. And if no one proves otherwise, we accept everything. So then we need some time window to have a chance that someone will detect that it's not okay. There is some fraud. Because of that, this proof is fraud proof that we have, for example, 7-day window for finding that something is not correct. And that's why optimistic rollups, while they are optimistic, have this big delay, and we need to wait a lot of time to confirm and finally confirm that everything is fine. Then we have zero-knowledge rollups. The other technology, the other idea that is based on this zero-knowledge concept. Instead of waiting until someone will find that something is not okay, we can utilize zero-knowledge proofs to batch those transactions and provide the proof, zero-knowledge proof, that everything is fine inside this batch of transactions. And then, as it was previously said, we can easily check, validate this proof instead of replying all the transactions and checking whether the final state is okay. We have only proof that shows that everything was fine. And this is working because of zero-knowledge proofs, because we need to have a technology that allows us to generate this proof that will state that everything is okay, but will not reveal all the data that is inside such a batch, because that it would be counterproductive. And then we have various rollups like Starknet that was described, Zk-Sync, and so on and so on. But then we need to return to this idea, what in the end is this zero-knowledge proof? In general, the idea is pretty simple, because from the Wikipedia we can read that it is a protocol in which one party can prove to another party that something is true without revealing any information. In the other words, the zero-knowledge proof is a kind of pretty sophisticated mathematical technology that allows you to prove something without revealing the details of what you are proving. For example, I could create a proof saying that I'm adult without revealing my age. Typically, we need to show ID or something else to you or to you you will check, okay, I'm born, my birth date is this, today is this day, so you are adult. But I have just revealed my birth date, so you were able to validate I'm adult. Zero-knowledge proof is something that will allow you to say I'm adult without revealing any details, any personal data, let's say. The simplest way of implementing zero-knowledge proofs is called interactive zero-knowledge proof. It is just a series of questions between the dialogue between the prover and the verifier. They talk, and after each question and answer, the verifier is more certain that the proof is correct. That's why it is called interactive, because they need to talk with each other many times, and the verifier is asking and the prover is answering, and so on. The very typical way of describing interactive zero-knowledge proof, every time when you will read about zero-knowledge proof, there will be probably an example of the Alibaba cave story, which is a typical example of interactive zero-knowledge proof. So here we have a story when there is a Bob, let's say, the green guy, that wants to know whether this girl has known that whether she knows the password to the door, which is here. And how can and she needs to prove that she knows the password to this gate inside this cave without revealing the password, because obviously the simplest way would be just saying the password, but then the password has been compromised. So how we can implement the zero-knowledge proof here? Simply, they can agree that she will say, okay, I'm taking the way A, so the up way of going into this cave, and then, or B, for example, and then the guy that is checking the proof, so in this green guy here, is saying he came in also to this cave, and he is saying, okay, so now let's return return from this cave from the entry A. And if she knows the password, she will simply open this gate and she will come out from the entrance A because she knows the password. If she doesn't, sorry, it means that it was not, she was saying false. She was lying, she doesn't know the password. Obviously, this is the only one iteration. He may be lucky, she may be lucky, sorry. She may be lucky, so it could happen that he asked her to go into that entrance that she really entered. So we need to repeat these iterations many times, and with every repeat, the chance that she is lying is simply dropping drastically. But this is this interaction that we need to repeat many times, and then have we will be let's say certain that she really knows the password to this gate. Probably the description in the Wikipedia will describe you that much better than I did. And then we have another example of Sudoku. We can prove that we know the solution of the Sudoku, for example, by smart shuffling the real answer and providing proof of this shuffled solution. So the shuffled solution will be still correct, but we will not reveal this solution. This is another typical example of zero-knowledge proof, because then the prover will need to answer various questions about various elements from this puzzle, and after many iterations we will see, okay, probably we know the prover knows the correct answer because he's answering all the time correctly. But this is not good, because we know we want to have something fast and do not have any chatty protocol that is all the time talking between the prover and verifier. So this technology is not suitable for our purposes, but something like non-interactive zero-knowledge proofs has been developed. It is a purely mathematical stuff that allows to generate a proof of calculation simply and provide this proof to say that this calculation has been done and the result is this one, and here is the proof, but we will not have data that has been processed. We will just have the proof and the verifier that will be able to verify this proof. The verifier and the prover are part of this technology stack. So we have snarks and starks as they have been described previously. They have some differences. Both are based on zero-knowledge proofs. No trusted setup, faster, slower, whatever. Mostly what people are saying about snarks because they were first, but probably starks are better, I believe. So maybe the future of zero-knowledge proofs is more connected with starks. We will see. Obviously, zero-knowledge proofs are not only about rollups, because it is all about providing proofs without revealing data. So anonymous payments are using zero-knowledge proofs, like Zcash is using it, Rest in Peace Tornado Cash was using it, and so other solutions that were just to prove, for example, that I have paid, but without revealing what were the participants. And there are many other applications like the centralized identity and anything about providing information about yourself. There is very interesting startup, Sysmo, which is providing zero-knowledge badges, which are ways of proving things about you without revealing this information. So, for example, someone may require from you a proof that you have 10,000 followers on Twitter, and you will be able to create such zero-knowledge badge proving that you have an account that has 1,000 followers without revealing what's your Twitter account, simply because maybe you would want to reveal this information. And you can combine such badges, so I imagine in future many applications will require something like that. to save your privacy, but still to require something from the business perspective about you, like your age, like your salaries, like whatever we will imagine. And as it was also said, zero knowledge proofs may be related to privacy, so they are protocols that are utilizing this knowledge and blockchains written around this idea. But the problem with zero knowledge proof that it is a pure math, and it is really hard to write zero knowledge proof, prover, and it is super early stage of all this being developed. So like Cairo is pretty primitive language still, and the high-level languages that will utilize zero knowledge proof are just still emerging. So for example, one of the very first is this Noir language created by this blockchain, which is one of the very first ways how you can play by writing your own zero knowledge proof, generating a smart contract that will be a prover of it, and just play with this concept by yourself. So if you are interested about it, it might be one of the best ways to start learning. Or they are being used in various, like Chainlink has a Deco project, which is are oracles that are providing zero knowledge proof about the various things that you would like to use in your smart contracts. So this is all about proofs of things, and that's why I believe, and Vitalik is believing that, and many others, is the future of blockchain, because we need privacy. Like, blockchain is not a magic, and no one probably wants to give everything about making public. We need privacy, so they will be showing here and there. Then we have obviously ZK rollups. So this idea to apply zero knowledge proofs for proving these batched transactions. And then we have, I don't know how it should be written, because everyone is reading it in different ways. So ZK rollups, somehow like that. We are calling it zero knowledge proof, rollups, sorry. And yeah, I mean, both Vitalik and other pretty involved people in the blockchain technologies are saying that, like we now understand blockchain and what it in general is, in that same manner we will understand zero knowledge proofs in 10 years. They will be so common and so popular that everyone will understand, maybe not the mathematical basics, but at least the use cases and what we can do with them. So zero knowledge rollups are exactly the idea, how it was described previously. We are gathering and batching transactions and proving that all the data or the transactions has been processed correctly, and that they processed from this input to this output, and then here is a proof. The problem is with the data availability, because then the prover needs to, if we want to validate the proof, we need the data to check whether in the end it is a correct set of calculations and transactions that has been executed. So we have various data availability models for zero knowledge rollups. First of all, we have rollup, which is just called rollup, when the data is on chain. Which is not for privacy for sure, because as it has been said, Starknet is publishing the input and the output before and after the whole batch of transactions on Ethereum. So it is not private still, because the final, the state of your accounts before and after of those transactions will be still public. So it is not for privacy. We are utilizing this knowledge here more for scalability, but still all the data are on chain, which may be good or not, depending on the use case. Now, if it may be public, that's good. We are just putting it on the layer 1 on the Ethereum, and we are happy. The second model is called Validium, which is storing data off-chain, which obviously reduces costs, because we don't need to store all the data that are required to validate the proofs on-chain. That's cheap. We can put it somewhere else, but obviously the question is where, and then we need to trust those entities that are storing this data, so various blockchains are trying to solve it in various ways. For example, like creating trusted, let's say, decentralized operators that are storing this data. And devolution, which is just the mix of it, so we allow the end user to choose per transaction. Some transactions might be fully okay with having the data public, others may require to have this data off-chain, and this will be configurable per transaction. So in the end, when talking about layer 2 architecture, we have this set of possibilities. If we are talking about fraud proof, so this time window for proving that everything is okay, we have optimistic rollups and plasma. And then validity proofs, depending where we store this data, they will be called volition, validium, zk rollup. And if we look on the L2-bit side, we will see a lot of those solutions are in the end using, most of them are using these solutions. Although we have some optimistic rollups, we have ZK, most of them I would say, at least more than a half is ZK rollups, validiums, and that's, I believe, will be changing more and more. So even if we have validiums here, as far as I remember, most of them are StarkX instances, so another blockchain from the same company that is creating Starknet. Okay, I will skip this. I will skip this also because that was shown previously, how we can implement this rollup, whether it is fully Ethereum compatible or not. And then we have those two most popular blockchains, layer 2, utilizing, they are ZK rollups. So Starknet and ZK Sync, they are most popular one. I will not describe maybe because most of it was covered already. What is interesting here is to see the popularity of languages, and when we see here, we have Solidity, Viper, but the Cairo, which is the third one, here is the third one. Obviously the difference between the second one and the third one in terms of the total value locked in the smart contracts written in those languages is pretty huge, but still Cairo is getting popular. Rust is mostly winning, but at that time Cairo was, so I take a screenshot because I believe they will, Cairo for sure is getting more and more popular. So for me, 2023 is the year of ZK rollups for sure. We have Starknet going public, we have ZK Sync going mainnet, let's say. So that would be probably one of this year when we will be talking about it more and more. Anyone involved in Starkware software for sure knows that this is the year for it. And even from the investment point of view, obviously this is not any kind of financial advice, looking at Starknet or ZK Sync may be interesting because this is the year when they are really born to the mainnet. So when we look at this famous roadmap of Ethereum, we will see a lot of very fancy features that are going to be added to Ethereum, called in various ways, but 80% of these nice features are rollup centric. And to make Ethereum more friendly for rollups, for zero knowledge proofs, to the point when Vitalik and other Ethereum Foundation is fully aware that even if we provide better scalability by second layer, the first layer also is going to that direction. So in the end, they will combine both scalabilities and we will end up with really scalable solution. And I believe that's all.